Hello guys, welcome back to another video. In this video we will consider the following integral. Alright, to proceed we will introduce a substitution. Square root of x equals t. Squaring both sides and taking the derivative, we get dx equals 2t dt. From here we get 2 times the integral from 0 to infinity t e to the minus t ln of 1 plus 1 over t dt. And so using the property of the logarithm, we will break the integral in two. So we will have an integral from 0 to infinity, 2 times t e to the minus t ln of 1 plus t dt minus 2 times the integral from 0 to infinity e to the minus t ln of t dt. Alright, so we will focus on the first integral right now. So we will have an integral from 0 to infinity e to the minus t ln of 1 plus t dt. We will do this by partial integration. We will differentiate and integrate. So we will differentiate ln of 1 plus t and integrate t e to the minus t. From here we get minus e to the minus t, 1 plus t, and here we get 1 over 1 plus t. From here we get minus e to the minus t ln of 1 plus t times 1 plus t evaluated at 0 to infinity plus an integral from 0 to infinity e to the minus t dt. This integral evaluates at 1, and at infinity this will go to 0, and at 0 this will go to 0. So we just have 1, and 2 times 1 we get 2 minus 2, an integral from 0 to infinity e to the minus t ln t times t dt. So let me just scroll down a little bit. So we can realize that this integral is actually a partial derivative of the gamma function evaluated at s equals 2 of the following function, e to the minus t x to the s minus 1, t dt. So this is actually partial derivative of s with respect to s evaluated at 2, gamma of s. So this is gamma prime of s evaluated at 2. Evaluated at 2, so this evaluates to this. So what is the derivative of the gamma function? So we know that the derivative of the gamma function is connected to the digamma function, and digamma function is defined as the logarithmic derivative of the gamma function. Taking derivative of this, we get gamma prime of s over gamma of s, which is the gamma function s. So we have this function evaluated. So here we get first derivative of the gamma function is just gamma of s times digamma of s. We have this, and we need to evaluate this function using the gamma function property and taking the derivative. First we take the logarithm on both sides, and then we take the derivative with respect to x. We get 1 over x plus digamma of x equals digamma of 1 plus x. As we can see, we need this evaluated at 2. So we get 1 over 2. 1 over 1 plus digamma of 1 is digamma of 2. And digamma function evaluated at 1, we can show this that it is equal to negative constant, euler-macheroni constant. So digamma at 2 is 1 minus digamma. So back into our original problem, we have that gamma prime of 2 is actually gamma of 2 times digamma of 2. This is just 1 factorial times 1 minus gamma. So this evaluates at 1 minus gamma. Back into our original problem, let me scroll down a little bit. We had 1 minus 2 times the integral, and this integral is 1 minus Euler-macheroni constant. So we get 2 minus 2 plus 2 digamma. So what do we actually get? We get 2 Euler-macheroni constant. And that was it for this video. Thank you for watching and see you in the next one. Bye.